This is the screencast for section 3.5, example 3, solving a logarithmic equation. Well, this looks pretty straightforward. You may not know how to solve it yet, but it looks pretty simple. I am going to do this 3 different ways. 2 of the ways are going to be right, and 1 way is going to be wrong. So first, the log of x squared equals 2. Well, I can't solve for the x that is inside the log, so instead I'm going to change this to exponential form, which is going to make it a little bit easier. So that would be option 1. So instead of the common log of x squared equals 2, since that is log base 10, the base of my exponent will be 10. Logs find exponents, so the output of the log will now be the exponent of my exponential, and then equals x squared. So this means 100 equals x squared, and then I could take the square root of both sides, don't forget the plus or minus, and then x is going to equal plus or minus 10. So there's 2 answers. Now the next option, option number 2, since I have the log base 10 on the left, it'd be really nice if I had the log base 10 on the right. So I need to unsimplify that common log that existed on the right by using the one-to-one property of logarithms. And that would be option 2, the one-to-one property of logs, or basically unsimplify your log. So on the left side, I'm going to keep that as the common log of x squared. Now on the right side, if I wanted a log that would simplify to be 2, that would be the log base 10 of 10 squared. So I just unsimplified the right side as it was a log base 10 of 10 squared. Well, now if I have this property, the one-to-one property that says the log base 10 of x squared equals the log base 10 of 10 squared, implies that x squared equals 10 squared. And I'm back to where I was in the previous example, where I would take the square root of both sides, of course not forgetting the plus or minus, and then x equals plus or minus 10. Now that third option, which would be incorrect, would be to take the 2 as an exponent of x and drop it out in front of the log as a coefficient. Now, how are you supposed to know that's right, and how are you supposed to know that's wrong? Well, you're supposed to know that that's wrong here because remember, you can't take the log of negatives. Well, now in the original problem, a negative squared would have been a positive, so negatives would have been allowed. Now if you put the 2 out in front, all of a sudden negatives can't get put into this log anymore. So when I divide both sides by 2, I get the log of x equals 1. So I can change that to exponential. 10 to the first equals x. I only get 10. I'm missing the negative because I eliminated the square that was allowing negatives to get plugged in the first place. So that would be wrong. It kind of does the opposite of creating extraneous solutions. It leaves out solutions that you may not have known about before, which is also a reason why maybe doing a problem 2 different ways is a good way to check your work, as well as checking it on a calculator. The now try problem says solve each equation by the method of your choice, again leaving it wide open, and then support your solution by a second method. I'm actually going to do 3. I am going to solve this in 2 different ways, plus check it on my calculator just to be extremely thorough and make sure I have the right answer. I'm going to start by changing this into an exponential equation. So the base of my log is 10. The logs find exponents, so the exponent of the base is going to be 6, and then that it will equal x squared. 10 to the 6th is, 1, 2, 3, 4, 5, 6. Take the square root of both sides. Don't forget the plus or minus. So I'm going to cut those zeros in half now. So it's going to be a 1 with 3 zeros, which makes sense because the square root of 10 to the 6th would be 10 to the 6th to the 1/2 power, which would be 10 to the 3rd. So I get plus or minus 1,000. So I will make sure and check that on my calculator. I'm also going to use the one-to-one property. So if I have a log on the left side, it'd be nice if I had a log on the right side. So I'm going to leave the left side as log of x squared, but on the right side I'm going to do this as log, again, base 10, because the left side was base 10. Then I'm going to make 6 an exponent with also a base 10. So that would have simplified to the 6 on the right hand side. But now since I have the log base 10 of x squared equals the log base 10 of 10 to the 6th, that means x squared equals 10 to the 6th by my one-to-one property. And I've got the same situation I had earlier. Take the square root of both sides, remember plus or minus, and I have x equals plus or minus 1,000. So I put the left side into y1, the right side into y2, and I adjust my window. I know it's the x values are supposed to be positive and negative 1,000, so I went x min negative 1,500, x max 1,500, and then my right side is going to be y equals 6, so my y max of 10 was fine. And then I'm going to graph that and hopefully see the intersections. Yeah, they're okay. I think I'm going to cut out the y min a little bit. That's better. With the y min of negative 2, I can see that and calculate the intersections very easily. And now I can see that my intersections are negative 1,000 and positive 1,000, just as the x values I found in both methods that I used to solve this logarithmic equation.